The world of artificial intelligence has just witnessed a game-changing breakthrough. A new large language model, LLM, called DeepSeek R1 has stormed onto the scene, shaking up the AI research community. Released by a Chinese AI research team, this model is already making waves, performing at a level comparable to OpenAI's O1 model when it comes to reasoning tasks like math, coding, and scientific problem-solving. In this video, we're going to break down 3 key takeaways from the DeepSeek R1 research paper. How chain of thought, COT, reasoning allows the model to self-evaluate. How reinforcement learning, RL, helps it learn without being explicitly programmed. How model distillation makes powerful AI models more accessible to everyone. Chain of thought, COT, reasoning is a simple yet powerful method that enhances how LLMs process and refine their answers. Instead of just giving a final response, the model is prompted to explain its reasoning step by step, much like how a person might solve a math problem by writing out their work. This process allows users to pinpoint where mistakes occur and refine the prompt to guide the model toward better answers. Take a look at this example from the DeepSeek R1 paper. When given a complex math problem, the model doesn't just spit out an answer. Instead, it systematically works through the problem, making observations like, wait, let's re-evaluate this step, almost like having an internal, aha, moment. This method results in much more accurate responses compared to a direct answer with no reasoning. By using COT reasoning, DeepSeek R1 can even self-correct in real time. If it spots a potential flaw in its own logic, it can go back, analyze its steps, and try again. This technique is crucial for improving response quality and reducing errors, especially in complex tasks like coding and problem-solving. DeepSeek R1 takes a unique approach to reinforcement learning, RL. Instead of feeding the model direct questions and answers, it learns on its own, much like how a baby learns to walk. If you've ever watched a toddler trying to stand up, you know they stumble around, holding onto furniture, experimenting with different movements, and eventually figuring it out. DeepSeek R1 learns in the same way. This technique allows the model to optimize its behavior over time by constantly testing different approaches and selecting the most effective ones. For example, if there are multiple ways to solve a math problem, the model will learn to favor the shortest or most efficient method, as it leads to a higher reward in the learning process. The research paper reveals an interesting finding. While OpenAI's O1 model remains static, DeepSeek R1 continues improving through reinforcement learning. The more it trains, the more accurate it becomes, showing a clear upward trajectory in performance. Given enough time, it could potentially surpass current models and approach near-perfect accuracy. But how does this work under the hood? Reinforcement learning operates by optimizing a policy, essentially the set of rules that guide the model's decisions. To keep training stable, researchers use a technique called policy clipping, which prevents the model from making drastic changes that could lead to erratic behavior. It's the AI equivalent of keeping a baby from falling over too often while learning to walk. DeepSeek R1 is a massive model with 671 billion parameters, requiring thousands of GPUs and high-end computing resources to run. But not everyone has access to that kind of hardware. This is where model distillation comes into play. Model distillation is a technique where a larger AI model teaches a smaller model how to think and respond in a similar way. The goal? to create a smaller, more efficient version of the model that performs just as well but requires far fewer resources. The DeepSeek researchers successfully distilled their massive model into smaller LLMs like Llama 3 and Qwen, reducing the size to around 7 billion parameters. These smaller models still achieve performance levels comparable to their larger counterpart, making powerful AI more accessible to researchers, developers, and everyday users. Surprisingly, during training, the student model sometimes outperformed the teacher model, demonstrating that AI can continue refining itself through reinforcement learning and distilled knowledge. As shown in the paper, these distilled versions of DeepSeek R1 even outperformed other major models like GPT 4.0 and Claude 3.5 Sonnet in tasks related to math, coding, and scientific reasoning. DeepSeek R1 is more than just another language model. It represents a major step forward in AI research. By integrating chain-of-thought reasoning, reinforcement learning, and model distillation, it not only improves its own accuracy but also democratizes access to high-level AI capabilities. The future of AI is unfolding right before our eyes, and it's an exciting time to be part of it.